Good afternoon to our respected teachers and my dear friends. Today we will be presenting our project on developing Battleship with an original storyline using Unity. Due to a major time constraint, we will dive right into our presentation. I am Somrita Ghosh and my teammates are Sritama, Manisha, Bhaduri, Nilanjana, Thakur, Sanjana, Poddar, Sriparna, Banerjee, and we have been guided by Professor Srijani Moitra. Now, I shall start the presentation by introducing you all to the classic game of Battleship from which our game is derived. So, Battleship is a two-player guessing game which has both computerized and board game versions. As we see in the picture, there are two 10 cross 10 grid. Each player hides 5 items in one grid and finds the items hidden by the other player in their grid. The player who finds the 5 item first wins. Change. We chose a topic of entertainment because we find games really challenging and exciting. Using our knowledge of computer science to work on something that we love made it easier for us to give our best and also helped us to spend quality time on something productive during this monotonous pandemic. We chose this particular game of Battleship because it is a well known NP complete problem. It may seem like a simple board game, but there has been extensive academic research in this field which continues till date. The most challenging part of the game was developing the AI which could decide what turn to play next to win and actually defeat a human being in the process sometimes. Change. We used Unity as our game engine because it is free to use. The programming language used is C Sharp, which, being an object oriented programming language, is very similar to Java, which we already know. There are abundant tutorials available that helped us learn and also saved us when we got stuck at certain points. It has an inbuilt collab feature which allows multiple people to work at the same time and share their work. Also, the visual support and UI designing feature of this platform is great. The table here shows the softwares we used in addition to Unity. We use text editors or IDEs for writing and editing scripts. Since our game is rich in visual and audio features, we needed to edit those assets. We used image editors for cropping, resizing, sharpening, changing, and removing backgrounds of images. For editing audio clips, that is for cutting, joining, amplifying, and fading sounds, we used Audacity. Now, may I request Manisha and Sritama to take over?
Thank you, Somrita. I, Sritama De, and my friend Manisha Bhaduri will now give a demonstration of our work. Battleship is one of our famous classic childhood games that we have been playing through all these years in the same old-fashioned way. Now, let's spice it up a bit. Our game, The Last Stand, is a twist on the classic game of Battleship. We have added a storyline and also made a few changes to make it as our own version. It is a fantasy fiction game which unfolds with the benevolent ruler desperately trying to save his or her kingdom, ERNAK, from the clutches of an evil witch, Ophelia. Now, let's jump into the demo.
Statutory warning. Before we start, we would like to point out that our design game is rich in audio. However, we will be turning off the music from time to time while giving a vivid description. So unfortunately, we might not be able to provide the complete experience over screen share. Well, here we present to you The Last Stand. As you can see, we have a customized icon on clicking which our game will begin.
This is the home screen of our game. It has the game logo, play, quit, about, music, and info buttons. The about button gives a brief description of our game. Music button gives us audio controls where we can turn on and off the music and sound effects of our game. For the time being, we are keeping the music off so that we are audible to you all. And the info button is an Easter egg that we're keeping in store to be revealed later on. Now let's play.
The story of our game starts here. The story scenes include a menu button which allows the user to pause and resume the game, change audio settings, and an exit button on clicking which you go back to the home screen. Also, to switch between the story scenes, we have provided next, previous, and skip buttons. The skip button takes us to the next decision-making scene. Since it's our first time presenting, we were bound to dodge showing the functionality of the previous and skip button. Now, we are turning on the music and it's time for the audience to immerse into the story and experience the world we have created. Please read along. This is the character selection scene. Here we let the player choose a character. If one decides to proceed without choosing a character, the game shows a warning because some story scenes are based on the character selected. Since we are the girls of Bethune, let's choose the queen.
This is the item placement scene. Just like Battleship, we have 5 items, but instead of water, we need to hide them in the kingdom. The kingdom is represented by a 10 cross 10 grid, and the items occupy 2, 3, 3, 4, and 5 cells. We have provided with the help button to assess the player while playing, a confirm button to confirm the placements, a random button for random placement. Every time you click this button, the items will be placed randomly on the grid, and a reset button to reset the position of the items. If you want to manually place the items, drag and drop them on the grid. And yellow highlight shows a valid position where you can place the items, and a red highlight shows an invalid position. If you try to place the item here, then an error message will show of invalid position and the item will go back to its last valid position. To rotate an item, you need to right click on it and then you can place it horizontally on the grid. If there is no space to rotate and you still try to rotate it, then an error message will show of invalid rotation. You need to move the item and then rotate it. As you can see, one last item is still left to be placed on the grid. In this situation, if you press the confirm button, a warning will show of incomplete grid. Now, let's place the last item and confirm our placements.
Here we come to the battle scene. There are two grids. The computer, or in our story the witch, will play on the left grid and you will play on the right grid. The computer has to find the 5 items you have hidden earlier and you find 5 items hidden by the computer. Here also, there is a help button. There is also a peek button on clicking which you can see the position of the items you have placed earlier. You start first. You start by clicking on any cell on the grid.
First shot hit. Nice.
Well, it's a good start then.
If there is a hit, you get another chance to hit, and if it is a miss, then the cell turns black and the opponents get to hit again. Second chance also hit.
Two items already. Keep going, Sritama.
Ah, she found it. Where should you think I should click, Manisha?
Maybe try in the first row.
Okay. Ah, bad luck. Second
Nice.
item gone. Third item. You need to find fast.
Yes. 4 items already.
As you can see, when the opponent is hitting, the cursor is replaced. Oh, I got a hit. The cursor is replaced by an hourglass, so you cannot hit again. Wow, I'm on fire today.
Keep going, Sritama. Keep going.
I am winning. Yes!
Yes, we finally did it. It was a tough competition. And now we move on to our final story scene.
This is the end scene. So we have two buttons, replay and exit. Now let's quit from the game and have a look how the game would have turned out if it was a defeat. Since we didn't know the outcome of the game, we have incorporated both the end scenes in the presentation. And this is the loss scene. If it is a defeat and the opponent wins, then the items which are not found by the player is shown on the grid, and then it goes to the final scene.
With this, the demonstration of our game comes to an end and we hand over the proceedings to Nilanjana.
Your screen is visible, Nilanjana.
Thank you, Sritama. I hope you all enjoyed our demo. As part-time gamers and full-time computer science students, we were keen on creating a game with a brain. I am Nilanjana Thakur, and I will explain to you how the brain of our game has been programmed to think. In our game, the artificial intelligence, or the AI, has two main purposes. The first of which is placement. As you saw earlier, the AI must hide the holy items to be found by the player randomly within the grid. But why did we adopt a random placement strategy instead of a specific algorithm? The answer is simply to avoid patterns and to make the placement unpredictable. The second and the most important role of the AI is to make optimal moves during the turn-by-turn gameplay in the battle scene to find the evil items that are hidden by the player. I will now break down how each of these functions are being performed. First, we come to the random placement algorithm. There are 5 items to be placed. They are of sizes 5, 4, 3, 3, and 2. They are to be placed in descending order of their sizes to minimize overlaps. Now, according to the flowchart, in each iteration, we must check whether all items have been placed successfully. If the answer is yes, we terminate our algorithm. Otherwise, we choose the largest item, say of size S, that is not yet placed. Then we choose a random direction out of horizontal or vertical to place that item. After that, we must choose a random valid starting cell index XY to place this item. From this adjacent grid, you can see that for an item being placed horizontally, the value of X can be any value between 1 and 10, but Y must be restricted to 10 minus S plus 1, where S is the size of the item. Similarly, for vertical direction, the value of Y can be between 1 and 10, but X must be restricted to 10 minus S plus 1. This restriction is being imposed to prevent the item from extending outside the grid as seen in these invalid placements. Now, after choosing a valid cell, we must consider S number of cells starting from and including that chosen cell. If any of them are already occupied, we say that an overlap has occurred and the process must be repeated starting from choosing the random direction. Once no overlap is found, all the selected cells are marked as occupied and the item is marked as placed. This same method is repeated until all items have been placed successfully. Next, we come to the turn-by-turn game playing algorithm. There are 4 primary battleship playing strategies known to the world till date. From the graph on the left, we can easily compare the performance of these 4 strategies based on their average number of moves required to complete a game. Random shooting, being the easiest to implement, is also the weakest in efficiency, requiring on an average 96 moves to complete a game. Next up are the 2 variations of the hunt and target strategy, requiring 65 and 64 moves each. And finally, we come to the most efficient strategy, requiring just 42 moves to complete a game. This is the probability density algorithm that we chose to implement in our project. Here, the probability density value of a cell refers to the likelihood of an item being on that cell. Now let us understand how these values are being calculated by the AI. For each cell, we need to count how many different ways each item can be placed involving that cell. Let us consider an item of size 2. The cells marked in green are some of the cells being considered, and the red lines show some of the orientations on the cells of the green color. Now, as we can see, this corner cell can have only these 2 ways of placement, so its count becomes 2. For this cell at the edge, there can be only 3 ways of placement, and this cell in the middle of the board can have these 4 ways of placement, as shown by the red lines. On the right is another example showing the various orientations for an item of size 3. This similar counting procedure is repeated for items of all sizes for all cells. But what happens if there is a hit or a miss on the board? The diagram on the left shows the orientations for an item of size 4 in the absence of hits or misses, but the one on the right has 2 miss cells colored in black. By rule, an item can never be located on a miss cell. This eliminates some of the orientations that were previously present on the left side grid, and the count of this green cell drops from 8 to just 3. Similarly, the presence of active hits also affects this count. An active hit, as shown in blue, is a hit on an item that is yet to be completely found. Here, the count of a particular cell, say this green cell, is counted as the number of orientations of an item that can cover both this green cell and this active hit cell in blue. For an item of size 3, it can be placed in only one way. But for items of size 4 and 5, they can each be placed in 2 ways. As we can see, an item of size 2 cannot be placed in any way such that it covers both these cells. It is also important to note that the other two green cells have a count of 0, as it is impossible for any item to cover those cells as well as the blue heat cell. After computing the probability density of each cell, the obtained grid for each item is represented as a heat map, where green indicates the highest density and red indicates the lowest. The superposition of the heat maps of all 5 items gives rise to the initial probability density grid. As evident from the diagrams, the maximum density values will initially always be concentrated towards the center of the grid. But this computed grid is not constant. In fact, each time before the AI makes a move, it must be cleared and recalculated according to the current game board, keeping in mind the positions of hits, misses, and found items. The cell with the highest probability density value is selected as the next best move of the AI, and a tie in values is resolved randomly. Here are the heat maps of 4 such instances of the grid computed at various stages of the game. The first one shows a board with an initial miss at the index 5,5. As we can see, the density values of the neighboring cells in its row and column have decreased considerably. The second is for a board with an initial hit at the index 6,6 as shown in blue. As we can see, the neighboring cells have values that are increased greatly. This helps the AI to approach finding the item which has already been hit. The other two heat maps show boards from the middle of the game where 2 items, as shown in white, have already been found. In the third heat map, the AI is still looking to hit another item, while in the fourth, the AI has already hit parts of another item, as shown in blue, and is trying to find it completely. Thus, this is the probability density grid which is looked up by the AI in each step of the game in order to make educated guesses and thus to transform itself into a fun and satisfying human-like opponent to play against. And with that, we come to the end of the computational aspect of our project. I hope I was able to provide some insight into the brain of our game. Now, I will hand over the next part of the presentation to my teammate Sanjana.
Thank you, Nilanjana. In the last 3 months, with hard work and our best efforts, we have successfully developed the AI that can win this game against anyone. My name is Sanjana Poddar, and in this case study, I will reveal how we can trick the AI into losing the game. As you know, our game is based on probability density algorithm, which assumes that the items are random and uniformly distributed over the board. With the help of this flaw in the logic, we can deceive the AI. For that, we need to place the objects in a skewed manner over the grid. In this shown example, they are placed on the leftmost corner of the board and are closer to one another as if they are in the same neighborhood. With every move, probability density values of cells changes. For instance, if the 5-celled object as highlighted by the blue box is found, in the corresponding heat map, we observe that the greener cells, which are most likely to be hit by AI next for their high density values, lies far from the identified object. This happens because the game AI assumes that the objects are randomly distributed and uniformly placed all over the board, which causes a drop in the probability to search an already hit and found region. Thus, the AI gets tricked as it now tries to locate the remaining objects in the greener regions of the board, whereas they lie hidden in the low-density yellow neighborhood of the identified object. With this being said, I don't want to admit, but there are some limitations in our game which we could not overcome and would like to improve upon in the future. First on the list is game AI does not use learning AI. The game is designed against random players. If a user plays repeatedly this game, he can figure out this cute placement grid setup and trick the AI. The reoccurrences of this situation can be handled if we implement learning AI in our algorithm. As developers of this game, we felt there is absence of complexity in game playing rules. The last stand follows a very simple set of rules and after a few matches can bore out the player. The lack of power-up tools and unavailability of difficulty parameters and levels are something we would like to work on to make this game better. Lastly, let me point out that there is major presence of luck factor which just cannot be avoided at any cost. Both the parties have to be lucky enough to hit all of the cells hiding the items before their opponent does for a win. As I come to the end of my part, I hope when you play this game you have a good luck and our AI has better than yours. I now hand it over to my teammate Sriparna.
Thank you, Sanjana. I am Sriparna Banerjee, and now I will talk about the future scope of our game. First, the algorithm we have used in this game is best till date. But in future, even better algorithm can be made which will end the game in much lesser and better moves. Second, a track of high score can be kept so that the player can come back to challenge with his or her own scores. Third, learning AI can be implemented to store the result after each and every game and learn from it to improve and play better in the next game. Learning the opponent's move and thinking process will make the artificial intelligence closer to human intelligence. Fourth, multiple levels can be introduced in the game along with various power-ups in order to let the player win the game. Fifth, the scenes that are shown in this game can be improved by addition of multimedia, mobility, and liveliness to the characters. The background can be made even more dynamic along with various sounds which would be more relatable to the story. Lastly, a mobile version of the game with touch control can be developed especially for Android version as it is a very popular platform for game engines. Our final words. We have used Unity, the most popular game engine, for developing our game. Along with it, we have learned the C# programming language. So, we can say that we have developed the skill set to call ourselves an amateur game developers. Second, most popular video games do not give us the opportunity to choose the gender of the central character. For example, our childhood favorite game, Mario, had a male character. When we, girls, played it, we had to be Mario as well. We did not get to be Maria, right? As student of Bethune, we found it important to include the character playing aspect in our game. However small this feature, it goes a long way in balancing the usually testosterone fueled world of gaming. Third, the Battleship game, which was once played using pen and paper, is given a new touch by addition of a fantasy fiction story along with animation, music, and sound effects. We even have customized the cursor to give the user an experience of entering into a different reality. Fourth, while doing this project, we even have learned how to work as a team, and by dividing the project into small modules has helped us to complete our project faster. Lastly, this project has been an amalgam of our love for game and knowledge of computer science. Working on it has never felt tiring. Instead, choosing something we are passionate about has been our greatest motivation. We now conclude with a valuable life lesson for all. Choose a job which you are passionate about. Then the job will no longer feel like a burden to you. Due to time constraint issues, we are unable to give proper credits to our references that we took help from, but they are well documented in our project report. Now, to wrap up our presentation, I would now like to hand it over to my teammate Somrita.
We have almost come to the end of our presentation. Now it's time for our story. The info slide, which was not revealed during the demonstration of the game, is about us. The team of seven that always had each other's back in moments of both agony and ecstasy, not only for this project but for the major part of our college life. Finally, this is us bidding farewell. As our extremely emotional journey in Bethune College comes to an end, here we are making our last stand. That is all we have to say. Thank you to everyone for listening. Now we are ready to face some questions.